forces and vectors, you guys have a parallelogram. They add up, you said 180. So what does the x have to be? 150. Good job. All right. Other things about a parallelogram. If this angle is 30, this is 30. Good. All right. And then the other one's going to be 150. And opposite sides are also congruent. That's as much as we need to talk about with the properties. But those are really important, especially the idea that two consecutive angles add to be 180 degrees. So this force and vector idea is, you guys will do this in physics, but it'll be a little bit more in depth. This is just kind of like an intro to it. So a vector is something that has both direction and magnitude. Magnitude is like size. And they show what direction it is by like an arrow going that way. And the magnitude is shown by like the length. Now, if you have two forces, if I take this all things good right now. Allison, perfect. All right, so this is not a really good example because I want to look super strong. Like go away. That's okay though. Hey, we'll use you. Okay. Not saying you're not strong. I'm sure you are. But totally backburning. Okay, so if me and Allison are both going to reach for her cell phone and we're both going to grab this, okay, hang on, so I have to talk about this phone. We're both pulling with a force. I'm pulling with the force this way, she's pulling with the force the other way. Let's say Allison is super strong. Oh my goodness. Going with her. So her force is way stronger than mine. What direction do we go in? Yeah, because she was a little bit stronger, right? So when you guys are drawing your picture, this resultant is kind of like what would be produced by the two forces, right? Now, if there was someone like with two equal forces, right, it gets a little, we have like an extra thing, but usually they're not equal.
Not equal?
What? This one? We don't know. We just know that when you guys draw them, right, you're going to have two forces. And what we want to do is make them into a shape that looks like a parallelogram, because usually they're not drawn for you. Once in a while, they're nice on a region, so we'll start the picture. So you're going to have one force down here and one force going up. And when you guys make this, let's see, into a parallelogram, okay, kind of just like finish it. It doesn't have to be perfect, right? But we're going to kind of make it into a parallelogram, right? And your forces, we want to make the larger force, bless you, on the bottom, and the smaller one on the side. Because if you guys think about a parallelogram, if this length is longer than the side length, it's going to be, the magnitude is going to be a little bit larger. So we want to make it at least as most realistic as we can. Now, bless you. Allergies are like in full effect. Yeah. This is really, really important. The resultant, okay, this line going through does not bisect the angle between the two forces, so we cannot say that the resultant cuts these in half. Right? I know it looks like it, but we can't say that it exactly bisects it unless the two forces are equal. So unless they say that you have two equal forces, we can't say that it cuts it in half. We're going to be using the law of sines and law of cosines, depending on what they ask us for in the problem. So it could be a lot of like drawing pictures, labeling things based on the information they give us. But we're going to solve by the law of cosines and law of sines. All right. But picture is super important. So let's actually draw one of these and kind of see what we got going on here. Okay. So two forces of 20 and 41 pounds. Now you guys are going to tell what kind of problem it is because you're going to see the words right in, like forces, magnitude, vectors, resultant, pounds. They usually have like all those keywords in it. So my two forces, 28 and 41. Right, so I'm not going to read the rest of the problem. I'm just going to start by drawing my two little forces. Okay, so I have two forces. And we want to make it like semi-resemble a parallelogram. It doesn't have to be perfect. Right? So I'm going to put my larger force on the bottom. So I'll make this one my 41, and this one my 28. Now, the angle between the two forces is 72. So let's say the angle is 72. Make sure you guys really pay attention when you're reading what's a side and what's an angle, because they don't usually label too much. So the angle between the two forces, we're talking about this part right in here, is 72 degrees. Find to the nearest pound the magnitude of the resultant. Well, the resultant is going to be kind of like the line that goes through the middle. It doesn't cut it in half, but it goes through. It's like what the two forces would produce. How are you guys with like the picture part? Good. So far, is everyone okay with reading the info and like putting it onto the picture? Okay. All right. Now, since we want to find the magnitude of the resultant, we want to know the length. Magnitude, okay, way back up here is shown by the length of something. So if they say the word magnitude, they want us to find how long that resultant is going to be. So what we're going to do is kind of make this into a parallelogram. Okay, again, does it have to be perfect? No. But let's label all the stuff we know. 41's down here, so 41 would be up top. This side would also be 28.
One of them will be 72.
Good. This whole thing would be 72. Oh, very nice. Now, Carly's got the main point of this, okay? They always like to kind of leave you guys hanging with something extra you need to find. Because we can't use this 72 degrees, because what's happening to it? It's being cut, and we don't know it's not being bisected, because these two forces are not equal. So we can't say that it's being cut in half. What we need to do, and this is like always your big thing that you need to find, is the consecutive angle. Right? And Carly, you said that angle was what? 108. Okay, remember they have to add up to be 180 degrees. So this is 108. That's 108 too. Are we doing okay so far with the labels? All right. Now this is kind of confusing. I don't know about you guys. If it helps you to take the triangle apart now and just figure out what you're looking for, okay. If we just use the top part, we can't use the 72 because it's being chopped. But we know there's a 108 here. We have a 28, a 41, and there's your x. Okay.
So what do you want?
Think about how many sides and how many angles do we have? Cosines. Yeah, because we have 3 sides and 1 angle. So we're going to use law of cosines to figure this out. Now the solving part, you guys know how to do. Hoping this is going okay. So make sure cosines start with your angle, cos 108. Okay. With a cross in the triangles, go to cross in the equal sign. So way over here should be x squared. Okay, the other 2 sides, just fill them in. Is there one in there, Andrew?
Oh, I didn't.
Okay, just bring it up and running. Things just shut down. Make sure your calculators are in degree mode too.
What do we round to?
Oh, yeah, nearest pound is the nearest whole number. So just make sure at the end you remember to take your square root to get x. Did you get it?
Yeah, that's what I got.
So nearest pound would be, yep, whole number, so 56. You didn't get 56? Did anybody else get 56?
Oh wait, I never mind. I got it. After asking for it.
Okay. 56 pounds. Yeah, make sure you guys remember to get rid of that x squared by taking the square root.
So that's what the.
That's it.
Oh, okay.
Yeah. The hardest part, guys, is like drawing the picture and like labeling things and kind of really understanding what they ask you for. It's not the solving part of our book. Here's another one. 2 applied forces produce a resultant force of 18.6 pounds. All right. So again, I'm not going to like overread anything. All right, I got 2 forces. They produce a resultant of 18.6. Okay. So just from that one part alone. Yeah.
So then you already know that.
Right. So, yeah, it's set up a little bit differently. That's why, like, it really depends what you're going to use law of sines or law of cosines based on what they actually give you. So this time, I know my resultant force is 18.6. I'll write that in. 18.6. Okay, let's continue here. So the smaller force measures 15.8. Okay, so here we go. So this one's 15.8. And the larger force is 24.3. Oh, all right, great. 24.3. Okay, so this one's 24.3. So find the measure of the angle between the two forces to the nearest tenth. Ooh, okay, well, let's see. All right, so they want us to find the angle between the two forces to the nearest tenth. Oh my goodness. All right, well, let's see what we know here. This is 24.3, so what's the top going to be? All right, and then, let's see, the side's going to be 15.8. Okay, well, if I want to find this angle, I want you to think about this. Can we use this triangle because it's getting chopped? No. What do you think we need to find first? The obtuse angle. Good job. That's good. Okay, good. We're going to have to find this top one first because that one's not getting cut. Now, once you guys know the top one, how could you get the bottom? Subtract it from 180. Good job. Yep. All right, so again, let's take out our triangle. If it helps you, don't have to do this if you're good at kind of seeing what's going on here. Okay, here's your angle. All right, what law do we need? Cosines. Good. We got to use cosines because we got 3 sides, 1 angle. So go for it. Set up your law of cosines. Make sure we're starting with cos x. On the other side should be 18.6 squared. Like drawing your picture? Yeah. Yeah. That's where people get like overwhelmed. But like just kind of like do it like we're doing, like just do one sentence at a time, you know? Sometimes when you read everything all together, it's like, oh my gosh, there's so much information. Hopefully you guys are using the chunking method here. Chunking things together. Can you get those? Very good.
How is that not? Why are you turning it by 18.6?
Why not? Oh, wait. Thanks. Should be 15.8.
Yeah, okay.
Thanks, Katie.
Okay.
Try that one more time.
Yeah.
67.88?
Yeah.
Oh, good. All right. Thank you. Thank you for saving me before I went too far. Make sure in here we're dividing. Oh my goodness. Okay, we should get cos x equals like 0.64355. Make sure you guys do a second cos. Did we get, let's see, what are we rounding here to? The same thing. Nearest tenth. Oh, be careful of this. Look at it. Watch out for this part. Okay. Nearest tenth. Make sure you guys don't round too much. This isn't our final answer, so keep a couple out. Okay. X here is 49.94. I'll say 28. Okay. Now, if you subtract this from 180,
Wait, did you get
130.1. How is that?
Good.
Good? Okay, this next one, I'm going to have you guys try to set up yourself. Okay? Alright. It's a two-part question.
Yeah. I put it in my calculator like the same way, but you know. Oh, that's right. What's in your calculator? Did she get it wrong?
Wait, no, okay. So yours is the ending answer. Yours is. I keep getting it wrong. This. You found this, right? 49.8, 49.48. You want this. You guys subtract this.
Wait, how did I get that?
Well, you just got
You're
that
not
like.
minusing the 3. You're not subtracting this part.
Oh boy.
You're subtracting 840.13 from that.
Okay. Two-part A first, guys.
You had this minus something else.
Okay, so that's enough.
Your answer minus this. So then
How?
subtracting this part and this part. You get an X. Like this came out.
It will be.
Oh, I thought we were talking about
This is one time the way you set it up. Well, you got 18 or 15. Oh, that's right. Sorry. I don't know. So here.
So wait, the first one you're finding the
Now, division, and then.
I don't understand. So
So
first you're finding this part. What's the result?
the resultant's at like that.
Wait, what are you?
If you need like help setting it up, I'll do a picture for you today.
No, don't start yet.
Oh, sorry, okay.
I don't know what.
Well, I think what it's saying is 2.1 will be the result. The small thing.
Okay. Yeah.
You're trying to find where does it goes in the back, definition.
I have 2 sides equal. There's no angle.
That wording is
Angle between the dash.
Everyone. Oh, okay.
Let's make sure we all have a picture right for A. So 2 was the measure of the angle between 32 pi 4. Right. A lot of us are messing this part up, guys. The resultant is the diagonal piece. So this is 50.1. Okay. Now, do they tell you guys the 2 forces? They only tell us one of them. So we have to pick. I mean, wherever you guys put your 30.2, did most of you do the little one or the big one? Little? Okay. So if you put it here, then the angle between these, just between these two, right? We're talking about this little piece, right? That's going to be 25.
So it's not
Not the whole thing. Now, if you put your 30.2 down here, your little piece would have been that little one, right? They're going to come out the same, right? No matter which one you did. Right, so when they ask you guys, find the magnitude of the second applied force to the nearest tenth of a pound. Well, let's fill in our reciprocity. Okay, well, you know, see, this side's going to be 30.2, right? Okay, so we want to know the magnitude of the second force. Well, what actually, if you guys take a look at the little triangle here, what's going to be the same thing as the bottom? The top, nice, Adam. So what about if we do this? Yeah. Okay, so this is 25, this is 50.1. You know that this is 30.2, and we don't know what this is. How could we handle this? Cosines. You got 3 sides, 1 angle.
Wait, alright. Do you have to like understand how to set up the
Draw the picture? Sure.
not really coming to me yet.
Oh yeah, you got 2 angles.
Resultant. I would draw your really standard, like definitely a result, standard angle, yeah. And then your resultant. Okay, I would start with that right away. Result is like the rest of them. Does that make sense? And the forces are always just like stagnant. Where's between them?
Oh, this is
Yeah, the little one. Yeah. There you go. All right. Now, find the measure again to the second applied force. So where's your second force? Yeah, good. Hold on. So, perfect. Okay. Now,
That's where we always go. Yeah.
just
Find
the
it.
whole thing.
you're not finding that whole thing.
No, side of it. It's just the way the result and that's the second
Oh.
Okay.
So sometimes you get
All you're finding is this.
well, no, he has 3, that was that. Oh.
That's right. I always redraw mine.
No, we already know that one. That's
There's a
yeah,
lot of
but
stuff
this
going
one.
on.
No, you're finding. Technically, you're finding that one. Okay. Because you like, they're on opposite forms, you know what I mean?
Yeah.
So the same.
Is
Yeah, I just like this. I
That's
for
for
like triangle
like
and
side.
everything. Like, before I found the first one, so then I was like between the result and side.
Yeah.
Yeah.
The one. I don't like part A.
You don't like part B? Yeah. 2, 1. Did we get far enough to see what the side was?
Yeah.
What did you guys all get?
26.07.
Yeah, 26.1.
21.
Well, it's just rounded.
I didn't. Yeah, I didn't.
I rounded.
Yeah, you're supposed to. Yeah. Yeah.
But
Because it
I'm
goes
saying
yeah.
an actual answer was like 20.
You're
Oh, it's
looking
still
for
there.
this is
Yeah, so it would have been 4.
So it would have been
They're not asking
21.
for the
I agree with
I
you.
didn't get
I'm just
one
saying the actual.
high force.
Without it being rounded.
Oh wait, sorry. This should be your 21.
But
Try one more time. Just type it in. You guys should be getting 26.1 here. Okay. And make sure that 26.1. Alright. Find the measure of the angle between the second applied force and result. Okay, so this time you guys are looking for the little baby piece underneath. The 15. No, it's alright, guys. You know anything. Come on. Right. Wait, can you guys just do what you just did though? Like, look at this part now. If you guys take this piece out again.
Cosine. If you put this in.
Okay. This is your x. Here's your 26.1. Yeah, you could do it that way. So you have this. You have a subtract, like, star 25. You've got to add like over 1. Figure out that way too. You're just gonna have like one extra
It
step.
doesn't work because we get 1840.
Good, you gotta chunk it up.
Yeah, my bad. Something that Oh no, this is the first 14 years. I can.
First I didn't know what to do.
How'd you guys do it here? Oh, how'd you get that? Shoulders, okay, show like, make sure you show like, make sure you like, show like what part you wear. Yeah. Are you guys getting 29 degrees? Yeah. Good.